Hello everyone, in this session of STR8CHEM, we're going to look at orbitals. But before we're going to go there, let's have a look at the key ideas of sigma bonds and pi bonds so that it would be easier for you to understand the reason why we need to know and we need to learn about hybrid orbitals. Okay? So, it is clear that when you want to know about bonds, you need to know that the formation of covalent bonds, it's the overlapping between two atomic orbitals. So you can have either end to end, or you can have orbitals overlapping side to side. So the two keywords that we can identify from the definitions of sigma bonds and pi bonds are this: you have orbitals, and then you have the word overlapping. Okay, so when you want to form bonds, we can conclude that when you want to form bonds, they are going to be formed when two orbitals are overlaps. Okay, and then the bonds that we are talking about here are covalent bonds. Okay, so when we want to form sigma bonds or pi bonds, we have to overlap two neighboring orbitals together. Okay, so the key idea over here is overlapping. But before we're going to look at how we're going to draw the overlapping of orbitals, it is very important for you to know the two types of orbitals involved in the orbital overlapping. The first type of orbital is what we call as the pure orbitals. And then the most important type of orbital that we're going to look at in this video, and then the other related videos, are the hybrid orbitals. Okay, we have pure and hybrid orbitals. For the pure orbitals, you have seen them before. Before you reach this point, you have talked about S orbital, P orbital, D orbital, and F orbital. So those are the types of pure orbitals. But when we want to talk about overlapping, we're always going to look at the two most important pure orbitals, that are the S orbital and P orbitals. We know that the shape of S orbital is like this, and then the shape of P orbital is like this. Okay, so those are the two pure orbitals that will be very important when we want to talk about orbital overlapping. So we have 5 hybrid orbitals that you need to know. So number 1, the first one is SP Hybrid Orbital. Okay, so why is it hybrid orbitals? Because to form these orbitals, you need to combine one S with one P to make SP Hybrid Orbitals. Why do you have 2 lobes? Because you have one lobe and 2 lobes. So when you have one S orbital and one P orbitals combined together, you would be forming SP orbital, and the shape is like this. So that is the shape of SP orbital. So it's quite confusing sometimes because the shape of pure orbital P looks exactly the same as the SP hybrid orbitals, but you don't have to get confused with this. Okay, so later on we're going to look at when do we need to consider hybridization before you want to overlap? Okay, so remember, the first hybrid orbital is SP orbital, and it will have 2 lobes, and this is the shape of SP orbital right over here. So the second one is SP2 hybrid orbitals. Okay, SP2 hybrid orbitals. It has 3 lobes. Why? Because to make SP2 hybrid orbitals, you need to combine or mix. Okay, you need to mix one s with 2 p orbitals to make SP3 hybrid orbitals. So when you add one s orbital with 2 p orbitals, you will get 3 lobes, and the shapes of SP2 hybrid orbitals is like so. So that is the shape of SP2 hybrid orbitals. Okay. The next one is SP3 hybrid orbitals. SP3 hybrid orbitals, which will have 4 lobes. Okay, so when you have 4 lobes, your shape will look like this. 1 lobe, the second one, the third one, and the fourth one. So that is the shape of SP3 hybrid orbitals. Why does it have 4 lobes? Because we have one s orbital mixed with 3 p orbitals to make SP3. Okay, SP to the power of 3. So that is your SP3 orbitals. You have 1 s orbital add with 3 p orbitals, pure orbitals, and you get this hybrid orbitals right over here, which is SP3. Next one is SP3D orbital. SP3D hybrid orbitals with 5 lobes. So you can guess that when you have 5 lobes, you're going to add 1 s orbital. You're going to have 3 p orbitals. And then this time you're going to add 1 d orbitals to make SP3D hybrid orbitals. That one is a clover leaf like that. So when you mix all of these pure orbitals together, you're going to form SP3D hybrid orbitals with 5 lobes. So the lobes going to look like this. So you have 1, 2, 3, 4, and 5. So that is your SP3D hybrid orbital. SP3D hybrid orbitals right over here. The last one for hybrid orbitals we're going to look at is number 5, SP3D2 hybrid orbital. SP3D2 hybrid orbital. So you can guess that it's going to be 6 lobes. Okay, for 6 lobes, you're going to have 1, 2, 3, 4, 5, 6. So that is how you're going to draw SP3D2 hybrid orbitals. So you have 1 s orbital mixed with 3 pure p orbitals mixed with 2 d orbitals. So you have s over here, p, 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 d, and d. So when you have all of these pure orbitals mixing together, you're going to have hybrid orbitals. That's why we call them hybrid orbitals, because they are not pure orbitals, but they are formed from the mixing of pure orbitals. Okay? So important notes number 1, hybrid orbital lobes. You need to remember this. So the lobes are only for the formation of sigma bonds and lone pair at the central atoms. Okay, sometimes you're going to have terminal atoms with hybridization, but that is a special case when you have multiple bonds, and when you get that kind of situation, you need to hybridize that one as well. So speaking of that, important notes number 2, you need to remember only central atom and atom with double bond or triple bond will get hybridized. Okay, so you need to remember that. Most of the time, your terminal atoms will not going to get hybridized. So we can look into those kind of examples in another video, but for now, it's very important for you to know how we are going to be producing hybrid orbitals. Okay, a lot of people might gonna ask, why do we need to form hybrid orbitals? Okay, the reason. So what is the reason for hybridization? The reason to make hybrid orbitals. Okay, the reason why the central atom, they need to form hybrid orbitals, mixing all the pure orbitals together, because they want to form stable overlapping of orbitals. So it is essentially a stabilization process to ensure that the molecule will be formed in nature, right? Now, so let's try to do this activity right over here. Okay, so let's say this is activity. States in exams, when they want you to state the type of hybridizations of the atom, you don't have to show your work. There is a scheme of work when you want to describe, when you want to explain hybridization, but in examination, in the question, if they say you have to state, you don't have to show those scheme of work, but you just need to write down what is the hybridization state type of the central atom. For example, over here, the asterisk is right over there. The star sign is located at the carbon. Remember, just now in the important notes number 2, we have stated that only central atom will be getting hybridization, and then all the H over here will not going to get hybridized because they are terminal atoms, and you do not have multiple bonds right over here. Therefore, only the central atom will get hybridized. Right, so what is the type of hybridization for carbon here? So the way you can look at this one, you have to look at how many sigma bonds and lone pair the carbon has. obviously here, carbon has 4 sigma bonds. So when you have 4 sigma bonds, that means you need to have 4 lobes. When you have 4 lobes, you are SP3 hybridization at carbon. So that carbon over here is SP3 hybridized. Okay, 4 lobes. 1, 2, 3, 4. 4 lobes. What about this one? We have 1, 2, 3, and obviously at your boron, it does not have any lone pair. So has 3 sigma bonds. Therefore, how many lobes? You have 3 lobes. When you have 3 lobes, means you're going to have 1 lobe, 2, 3 lobes. So that is SP3 hybrid orbital. So the type of hybridization is SP2 hybridization. So your boron is SP2 hybridized. Next, we have another one. Okay, we have another one over here without any lone pair at the central atom, but it has 1, 2, 3, 4, 5 sigma bonds. The P central atom has 5 sigma bonds. Therefore, it has 5 lobes. So when you have 5 lobes, you're going to have 1 lobe, 4 lobes, and 5. SP3D. Okay? So the type of hybridization on the central atom is SP3D. Okay? SP3D. Now, what about this one? Right now, at your central atom, you have 2 lone pairs. Okay, you have 2 lone pairs over here, 1 and 2 lone pairs. You have 1 and 2 sigma bonds. The oxygen central atom has 2 sigma bonds and 2 lone pairs. Therefore, how many lobes? You have 4 lobes. So for 4 lobes, we have SP3, 4 lobes. We do not have SP4, okay? We do not have SP4 because pure p orbitals, it has only 3 orientations: px, py, pz. That's why you only have until 3. Okay? SP3 hybridization right over there. Now, what about this? Another one with a lone pair. Okay, another one with a lone pair right there. Okay, 1 lone pair with 3 sigma bonds. the nitrogen central atom has 2 sigma bonds and 3 sigma bonds, 3 sigma bonds and 1 lone pair. So when you have 3 sigma bonds and 1 lone pair, that is 4 lobes. And 4 lobes is SP3 hybridization. So at here on your N, you have SP3 hybridization. Okay. So another examples. Right now you have two signs over there. So you need to state the hybridization for carbon and oxygen. Why is this one hybridized? Because just now in the important notes, I have told you that atom with multiple bond attached to it will also get hybridized. Okay. Now, so let's have a look at the carbon first over here. At your carbon, you have 2 sigma bonds at carbon central atom. It has 2 sigma bonds, and then it has 2 pi bonds. Pi bonds are not included in your hybridizations. The formation of pi bonds involve pure orbitals. So when you have 2 pi bonds over here, those 2 pi bonds are not going to be considered in the determination of hybridization type for carbon. So we're just going to take the 2 sigma bonds. So when you have 2 sigma bonds, means you have 2 lobes. 2 lobes means you have SP. So for C, the type of hybridization is SP. What about this one over here? Okay, so at oxygen atom, it has 1 sigma bond, and it has 2 lone pairs. So you have 1, 2, 3. Therefore, you have 1, 2, 3, 3 lobes. 3 lobes is SP2. Okay, so for the oxygen, the hybridization would be SP2 because you need to have 3 lobes. 1, 2, 3 lobes. Okay, so the last one, let's have a look at this one. You have 3 atoms. You need to identify the hybridization. So when you have a look at your carbon has 1, 2, 3 sigma bonds. Okay, so this one has 3 sigma bonds. And over there is a pi bond. Remember, pi bond is not going to get included in the hybridization. So when you have 3 sigma bonds, means you have 3 lobes. So your carbon right there is, this is SP2 hybrid orbitals. I'm just going to write hybridization. Okay, for that one. And then for this one right over here, you have 1 sigma bond, 2 sigma bond, and 2 lone pairs. Okay, so you have 2 sigma bonds and 2 lone pairs. So what does that's gonna tell you? So these over here is telling you that you have 4 lobes. 1, 2, 3, 4. So 4 lobes is SP3 hybridization. So that is SP3 hybridization. That is SP3. And what about that one? Okay, so for this oxygen, it has 1 sigma bond right there. So you have 1 sigma bond, and it has 1, 2 lone pairs. So when you have 2 lone pairs, 1, 2, 3. So you have 3 lobes. So 3 lobes means SP2. So you have SP2 hybridization for that oxygen. Okay?